So I'd confess that one of my favourite living artists is Bridget Riley. I love her sort of geometric op art style of work. And I think one of the paintings that most impressed me was seeing one of these circle paintings as a mural on the walls of Tate Britain. It must have been 2005, 2006, something like that. Really impressive piece of work. Her early work is lovely too. But we're going to have a go at trying to replicate something like one of these in side processing. That's quite a nice one, isn't it? Okay, so that's the idea that I'm aiming for here. So I've got a starting point of what I'm trying to create here. And the thing I notice about this is that we have overlapping circles. It's not an entirely regular grid. Some circles are present, some are noticeably absent. And we do have a very regular pattern here. So we're going to be working with that sort of idea. Let me move my browser tab out of the way. And here's a blank processing window. So I hope by now you've realized that we have two principal functions in side processing. We have the setup instruction, which is run once right at the start when the program is executed, and then the draw loop, which runs every single frame that processing draws. I'm going to work initially just inside this setup function. So we start with void and then setup, pass it no parameters, and start with the curly brackets that are beloved by Java programmers. Okay, so what are we going to have happen inside setup? Well, the first thing that we need is a screen. So we say let's have a screen size 600 dots wide, 600 dots tall, semicolon again. I'm going to fill that with white. And the code for white on a grayscale scale is just 255. That's the brightest possible value for each pixel. In other words, pure white. Okay. So that's got me set up, done here. Now what I'm going to do is circles on a grid. So let's get started with this. I'm going to do each row at a time. So I'm going to start with iterating over the Y value, how far down the screen I am, and then how far across the screen I am. So let's have this Y value for how far down the screen we are. We do that as a for loop. And then we have to pass it three particular commands to do. And the first one of those is to initialize the count variable for the loop. So I'm going to call that y for the height down the screen. So y is going to be an integer, and I'm going to initialize that, let's say 60 dots down the screen. We can play with these numbers later on. Okay, how far down do we want it to go? Well, all the way until it meets the height of the screen. So until y, we keep doing this until y gets as high as the height of the screen initially, these 600 dots, but it's nice to use the command for that. And then each time we go down the screen, we're going to increase y. So I really want here y equals y plus 60, and that's the third of the commands. There is a syntactic sugar for this. There's a shortcut for this, keep increasing by 60. So let's use the posh version of this and have plus equals 60 to just say keep increasing that number by 60. So that sets up the loop. What do we want to happen inside the loop? Well, actually the first thing that we want to happen inside the loop is another loop for each of the circles within each row of the screen. So I've got pretty much the same sort of thing going on here. For int x is 60 to start with, until x is less than until x hits the width of the screen, and then again x is going to be x plus 60, the old value, add on 60 to it every time you go around the loop. And I hope at least some of you have realised that we can abbreviate that as plus equals 60, just as we have done before. Okay, and curly brackets for the code that we run. What code are we going to run each time we go around these two loops? Well, what I wanted to do is just draw a circle, so let's do that. We have got a command which does an ellipse, and a circle is just a special case of an ellipse. So I want an ellipse centered on the x and the y coordinates with a width of 60. In each case I'm using exactly the same numbers there, semicolon to do that. Then we've got to close these loops. That's all I'm doing each time I tick around each of these loops. Close that curly bracket, close that curly bracket, and then that curly bracket is there for the void setup. I think I'm going to indent this a little, so increasing the indent of that code makes it a little bit clearer. To do that was on a menu command. Okay, so I can't see any problems with that. I'm expecting a regular grid of circles. Let's run the code and see what happens. The moment of truth, folks. And indeed we've got our regular grid of circles. I could stop at this point and feel quite pleased with myself. That looks like, I don't know, is that a wine rack that we've got there? That's not quite what Bridget Riley's work looked like. You'll recall that Bridget Riley's circles were overlapping ones. Let me just pull my browser back up into the screen recorder. Yeah, we've got that sort of overlapping pattern of circles. So let's see whether we can get a bit closer to that. Rather than moving across the full width of the circle each time, let's just see what happens if we only move half the width across. Sorry, half the height down and half the width across. Let's have a look at that one now. Again, running the code. Oh, now that's quite nice. Not what we were looking for. I don't know, some sort of tiling pattern. I could make a roof out of that, I'm sure. The problem, of course, is that the circles I've drawn are full of white paint. It's like Tipex circles, whereas Riley's work has these as transparent circles, doesn't it? It's just the outline of the circle. So we're going to need to fix that now. So each of these circles should not be filled in. So before we go round these two loops, let's have a no fill. Okay, no fill, which means make each of these circles transparent. Let's run that code, see what we get now. Oh, I love that. That's sort of a Islamic art type effect. I've got a little bit weird thing going on here that I've got a big gap at the start. Let's see whether we can finesse that. So rather than starting 60 dots in, let's start only half a width of a circle in and see whether that improves things at all. That's nice, isn't it? So yeah, I think, that reminds me a lot of the sort of Islamic art where there's no representation of anything living in there, and I think that's quite a beautiful pattern. But as we said earlier, Riley's work, it's not every single circle that gets drawn. There is what appears to be randomness to it. I don't know whether it is genuinely random in that she tossed a coin to decide whether to draw a circle or not, or she was looking for some sort of particular effect. Let's see whether we can replicate that by tossing a coin and deciding whether to draw a circle or not. So that's what we've got here is a sequence of instructions, big programming construct. We've got repetition. This ellipse gets drawn a large number of times. You could do the math there and work out how many times that is. In fact, we've got two sets. We repeat a repeating loop here. And the third big programming construct is this idea of selection of an if-then statement. And again, we're going to do that using processing code. So I'm going to toss a coin, which is this random idea here. I'm going to toss a coin with which produces a random number between 0 and 100. And I'm going to say if that random number is less than 50, so 50% of the time, then run the following code block. And my code block there, of course, is drawing my ellipse. Let's just tab that in a little so that we can see the structure of the code there. So this is a good point to pause your YouTube clip and have a look. Do you understand what this is going to do? Okay, do you understand the difference between this and the previous one? And of course, the thing that I've just added on here is this tossing a coin each time. If we get heads, then let's plot the circle. If we get tails, then let's not. Let's have a look at the code when it's run. Okay, and that, I think, satisfies my requirements of doing something a bit like what Bridget Riley painted. So I'm reasonably happy with that. As I said during the session, let's put that onto a big printer, use lots of ink to print that out, submit that to the summer exhibition at the Royal Academy and make lots of money at this point. Or maybe not. Okay, frankly derivative, as they say. I was asked during the lecture how you could animate this, and we can do that because remember we've not gone anywhere near this draw stuff. So we've got in processing the ability to do animations. So I'm going to go for void draw. Let me see, can I move the console window down a wee bit? Doesn't look like it. Okay, let's just go straight into void draw, and again angle brackets to get that all kicking off. Okay, what are we going to do inside each time processing redraws the screen? Well, it's got to be this bit, hasn't it? Okay, so let's take all of that code here, including all of its angle brackets, which I think are curly brackets, which are those, and lose that from that initialization setup routine and paste that into my draw loop here. Okay, we can run the code and have a look what happens. Okay, so it fills the screen very quickly. I'm not sure whether you noticed that. Look at right at the start. We start with random circles, and then, of course, we're just drawing circles right on top of one another. The thing that didn't work entirely well in the lecture was redrawing the background each time we go around that loop. So let's pop that down right at the start of our draw loop. So we clear the background every time we go around that instead of redraw the screen here. So I should warn any of you that may suffer from epilepsy to look away from the video for the next few moments, because this can be a little bit flashy. There we go, so we've got a very high-speed animation of lots and lots of frankly derivative Bridget Riley circle paintings going on. I think it would be nice, don't you, to slow that down a little. So we can do that by setting a frame rate here. And I think just 5 frames per second rather than whatever the default value happens to be. It's likely to make that a little bit more easy to understand what's going on. Let's run our code. Okay. Oh, that's quite nice, isn't it? Okay, so can we go beyond Bridget Riley circle paintings here? Well, of course we can. So what you've got is just drawing empty circles at each point. So let's, instead of having each of these circles entirely empty, let's actually colour each of these circles in. So if we're going to draw a circle, then we can fill it in with the colour of our choice. And we have 16 million different possibilities for what we fill each of these circles in with. So I'm going to do some just random colouring here. Random 255, random 255, random 255. So that picks any one of 16 million different colours. Close the bracket, semicolon at the end of the instruction. So we should see some coloured in circles this time. How beautiful is that? I don't know as it is beautiful, to be honest, but it's different at least. So let's stop that running. Now you notice that they were overlapping circles, and there's not much I can do about that because I'm colouring them in at this point. But we've got a 4th colour parameter. This is the amount of red, this is the amount of green, this is the amount of blue. So I can actually say, don't colour this in all of the way. Leave this as like 25% transparent, 64 out of 255. There will give us semi-transparent circles with a nice sort of colour tint to them. Let's run the code. I think that's better. I'm not sure that the big black outline to this works particularly well, so we'll get rid of that next. So as well as the size of the screen, let's have a no stroke command right up at the top there, where we're going to not draw the black circle itself. I like that. I think that reminds me more of Damien Hirst's work than Bridget Riley's work, but you form your own opinion about what you think about this. Okay, I'm going to stop that running. It's worth tinkering with these colour numbers here. So this is just picking one of 16 million different random colours. If I say don't include any green in this, just use a palette made up of reds and blues, then you get, I think, a much better, much more aesthetically pleasing, much more beautiful pattern of colours. Let's run that, see what we get. Nothing against the colour green, but I don't know, that somehow does more for me than just the random colours. I think because there is some sort of structure to this, we're imposing some sort of order on the chaos of just picking random colours. You can tweak those numbers to your heart's content. If you go to maximum green, I think this looks horrible. It's just too bright, isn't it? Rather than full-on red, full-on blue here, let's just stop halfway up. So 128, 128, let's run that. No, it's still not doing very much for me, I'm afraid. What about if we put this halfway as well? Okay. No, I think that's even worse. I was happiest when we had the 255 there, and the 255 there, and the 0 there. So let's just run that again. Yeah, that makes me happy. I'm quite content with that one. I'm going to stop the recording now and upload this to YouTube, so you've got a copy of this for yourself. And I think that was much better than attempting to do this, a very hurried sort of end of the lecture yesterday. Okay, thanks for watching.